Hello! Today we are moving on to a block of video lessons that will focus on solving of problems. Chemistry is an experimental science, but there's a lot of calculations involved in calculating substances. With calculations of chemical equations, the ability to predict, for example, what the practical yield will be. Such calculations are used, for example, in chemical production, when these calculations make it possible to calculate what the end product of a particular chemical production will be. For example, Gaber's synthesis, in which ammonia is obtained. In order to calculate what the final product will be, we would have to know how many reacting substances are involved, how much of the reaction product is obtained, whether there are no losses that can occur in certain chemical reactions. Well, and if we also take into account that many chemical reactions take place in a gaseous environment, then we would need to know what the volume of, for example, a gas would be, under what conditions these gases would be measured, whether it affects, for example, the creation of temperature or pressure of the reaction mixture. In addition, many chemical processes occur in solutions. So for solutions, there is its own category of problems that are related to the calculations as well. That is, as you can see, there are very many types of chemical interactions where calculations are used. So today you and I are leading a concept called quantity of matter. So the quantity of a substance itself is measured in moles. The amount of matter is usually denoted by the letter N, and it's calculated in moles. But the amount of substance itself in turn allows you to do a lot of calculations in chemistry. Firstly, the amount of matter can be related to mass. And mass can be measured most often in the calculations that we do. The most common ways is when we work in grams, although of course there can be calculations in kilograms and tons and so on. Mass is denoted by the letter M. The quantity of a substance is in turn related to the volume of gases. And in this case, the volume is usually measured in liters. But there are calculations, for example, associated with decimeters. Such a unit of measurement is also sometimes used. The volume is denoted by the letter V. In addition, there is also the concept of particles. And particles can be atoms. They can be molecules. They can be masses, respectively, which are related to the calculations, that is, the units of these particles. And particles are denoted by the letter N. Well, now let's establish the patterns that we have associated between the amount of matter and mass. So there are certain forms of recording these calculations. Well, let's start with mass. So to find the mass, we need to multiply the molar mass by the amount of matter. Notice that in this formula I've applied another quantity, which is denoted by the capital letter M. It's called the paint mass. And it's usually measured in grams versus moles. To moles? The molar mass for all chemical substances is set as a formula mass. That is, for example, for water it will be equal to 18. So from this formula we can derive derivative formulas. Well, for example, to find the amount of a substance, we need to divide the mass by the formula mass. And to find the mass of paint, we need to divide the mass by the quantity of the substance. But I would like to say that there is a wonderful triangular formula that allows you to combine all of these formulas into one. So this formula is highly recommended for your calculations. It is, first of all, easy to memorize, and then you can quite easily remember any of the above formulas, or you have to memorize them one by one. Well, for example, to find and work through this formula, you have to know how it's lined up. Notice there is a horizontal line here. This line means the line of division. There's a vertical line that means the multiplication line. Now let's see how this formula works. To find the mass, we need to multiply the mass by the mole. Here we have the mass, and here it is, this product, the molar multiplied by n. If we need to find n, notice here was mass divided by molar mass. Then to find n by the mass, you really have to divide by the malarial. And if the malarial was unknown, the mass divided by n. So this kind of triangular formula, I think, is visually very easy to memorize, and you will certainly remember it easily. Or you have to memorize a formula, for example, and derive from one formula, let's say, another formula. Now let's work with volume. To find the volume, you multiply Vm by a mole. In this case, Vm is one of the quantities that I have not yet given in this case. This is the so-called molar volume. And this volume, is a constant, and if conditions are normal, which are denoted by the letters STP, in which case it's 22.4 tenths, respectively a liter divided by mole, but that only happens at standard temperature, and in this case the temperature is 0 degrees Celsius or 273 Kelvin, and the pressure in this case is 10 to the 5th Pascal. But these conditions are normal conditions. Not always chemical reactions take place under normal conditions, so sometimes there are deviations when used for calculations. For example, the value of the derivative at room temperature, then this value will not be 22 and 4, but 24 liters per mole. And now let's derive the triangular formula for this formula so that we can use it and derive the necessary formulas from it. Look, it looks just like the triangular formula. At the top we'll have B, here we'll have Vm, here we'll have the amount of substance, that's the number of moles. Let's check. We need to find B, and then Vm is multiplied by N. And if we need to find H, pay attention, I have not given this formula. Let's deduce it from here. It will be B divided by Vm, well, and Vm then in this case B divided by N. And then we have particles. And it remains to explain how to work with particles. To find the particles, we need to find the Na multiplied by N, the number of moles. What is Na? Na is a named number called Avogadro's number. And it's a number that's a constant, and it's equal to 602 times 10 to the 23rd power mole in minus the first power. So, well, let's also give a triangular formula for this formula, which will allow us to do derivative calculations. So we want to calculate in this case the number of particles, or the Avogadro number, or the mole number. Again, working exactly the same way, we want to count the number of particles. Then we multiply Avogadro's number by N. If we want to count, for example, the number of moles, then we divide N by Na. Well, if the question was Avogadro's number, then we have to divide n by Na. So to do the calculations in chemistry, you need to know what certain calculated quantities are. When we work in the school course, it is certainly the amount of substance, but in the university program, universities introduce the concept of equivalent, which is necessary for you to learn how to make more complex calculations. But for now, we will not touch this topic. In the next lesson, we will learn to solve problems using all the proposed formulas. So be sure to watch our lessons and we'll learn how to solve these problems. Well, that's all for today. Goodbye.